Hello everyone. Today we want to quickly run through our chemistry practical for NECO 2025. Basically, we want to check our salt analysis, which is also known as our qualitative analysis. In this year 2025, we're given two basic salts, like two salts, inorganic salts. So we call them sample C and sample D, and we are expected to carry out series of tests on each sample. So now let's quickly run through our expected question or predicted questions and see how we are going to report during our test. Let's check this out. Sample C and D are simple inorganic salts. Now, the instruction says carry out the following tests on sample C and D. Record your observations and inferences. So, now identify the gas involved, if there is any. From our instruction here, we have number 1A. Put sample C in a test tube and eat. So what we are going to do, we are going to draw our table that will show the test, the observations, and the inferences. Now, seeing this table, we have test, we have observation, we have inferences. So question number 1 says, put sample C in a test tube and eat. So if you heat sample C, what you are going to get, we have a brown gas evolved. So with an irritating smell, that is the kind of gas that evolved. So when we tested the gas with litmus paper, the gas turns blue litmus paper red. So when blue litmus paper turns red, it means some between acid and base. We know that acid and base have an effect on litmus paper. So acid turns blue litmus paper red, while base turns red litmus paper blue. So this one turns blue litmus paper red. So what kind of gas are we talking about here? We have NO2 gas from NO3 minus is present in our sample C. Now, the second question says, put all sample C in a test tube and add 5 cm cube of distilled water. So it might be more than 5 cm cube, it might be 10 or 20. Just follow the instruction, but you definitely add distilled water. Then, shake gently and test with the litmus paper again. Divide the resulting solution into 4 portions. So, the first portion of our resulting solution, they said we should add in drops until in excess. That means we add it in drops and then in excess. What are we adding? Sodium hydroxide. So, these are our sodium hydroxide. Now, let's see to the second portion. We are going to add also in drop until in excess aqueous ammonia. That is number 2. So then to the third portion, we are going to add dilute hydrochloric acid. And then, so to the third portion, as we said, we are adding dilute hydrochloric acid. Then we will heat it and allow it to cool properly and record our observations and inferences. So to the fourth portion of our resulting solution C, so we are going to add potassium heptaoxochromate 6, which is K2Cr2O4. Then let's go and see how we are going to report properly for this test. We said from number 1 that we have a brown gas that is irritating, that evolved. So now, after dissolving sample C, this is a solid sample now. So after dissolving this sample C in distilled water, this sample C is solid plus water here. Now we know that we've added water. So sample C dissolves to give a colorless solution. So once we know that it dissolves, that means sample C, solid sample C, is a soluble salt. Now the instruction says we should test our solution with a litmus paper. So it turns blue litmus paper red. It means solution C is acidic. So the solution C, because it's already in aqueous state now, not more solid sample. Now B, we were told to put the solving solution first portion and add sodium hydroxide in drops, then in excess. Adding it in drops, what do we get? We have white precipitate, formation of white precipitate here. Now, when we put it in excess, the white precipitate dissolves to give a colorless solution. That means the white precipitate disappears and we have our colorless solution. Likely, what are we having in our inferences? So we have our lead. This shows that lead 2 or calcium 2 ions is present. So So, but immediately we see that the precipitate dissolves to give a colorless solution. That one confirms lead 2 plus, that it is the ion that is present, which is our cation. Now, the second portion of our resulting solution, instruction says we should add aqueous ammonia plus ammonia in drops, then in excess. What do we have? We still have white precipitate formed. Now, when we put it in excess, the white precipitate remains insoluble. That means the white precipitate here does not disappear. So, in essence, aqueous ammonia, it shows that lead 2 plus is present, and when the precipitate remains insoluble, it shows lead 2 plus is confirmed. Now, the third portion of our solution C plus dilute HCl, and then we heat it and allow it to cool. What do we have? When we put our dilute HCl, the white precipitate is formed, and the white precipitate dissolves on heating. So when you are heating it, the white precipitate is here, it dissolves to form a colorless solution. You can see the repetition of the same characteristics of our cation here. Now, on cooling, what do we have? The white precipitate reappears on cooling. That is to say, aqueous sample C plus dilute HCl, there is formation of white precipitate. Now, it shows that lead 2 plus is present. So, heating it, the precipitate disappears on heating. So, when you allow it to cool, the precipitate reappears. So, it shows that lead 2 is actually present in this sample C. And to the fourth portion of our sample C, the instruction says we should add K2Cr2O4, which is known as potassium heptazochromate 6. Now, when you add potassium heptazochromate 6, what do we have? A yellow precipitate is present. Yeah, we have the formation of yellow precipitate. This actually confirms lead 2 plus. Lead 2 plus is confirmed here. Now, this is the end of the question number 1. So now let's go back to our question and see question number 2 and how it's going to instruct us. We are going to carry out the same test on sample D. So the question says, put sample D in a test tube and heat as well. Put one sample D in a test tube and add 5 cm cube of distilled water. Shake gently and test with litmus paper. Divide the resulting solution into 2. Now, to the first portion, we had barium chloride, which is barium chloride. To the second portion, you had dilute hydrochloric acid, which is HCl. Now, let's quickly run through the test for our question number 2, which is on our sample D. The instruction says we should put D in a test tube and heat. Putting our D in a test tube and heating it, we have lilac flame observed. Yeah. So anytime you have this lilac flame observed, it shows that potassium ion is present in our sample D. So in our inference, you write that potassium ion is present. Now, this instruction says we should put distilled water in our sample D. So this is our sample D plus distilled water. So sample D dissolved to give a colorless solution. It shows that sample D is a soluble salt. And test with the litmus paper. This is our litmus paper test. So our sample D turns red litmus paper blue. So this shows that solution D is alkaline in nature because now it is in aqueous form because we already dissolved our sample D in distilled water. So it's now in aqueous form. Second part of our question says the resulting solution of sample D plus barium chloride, that we should add barium chloride to it. So adding barium chloride to it, what do we have? We have white precipitate formed. So this white precipitate form shows that either we have SO3 2 minus, SO4 2 minus, or CO3 2 minus might be present in this sample D solution. Now we proceed to the last part of our question, which says add dilute hydrochloric acid to your sample D solution. So when you have dilute hydrochloric acid, what do we have? The white precipitate forms which dissolve in dilute hydrochloric acid. Then a colorless gas with an irritating smell is also e formed. Then this gas turns blue litmus paper red. Then when we now use potassium permanganate to test this gas, it decolorize the purple color of potassium permanganate. So it shows that this dilute hydrochloric acid adding with our sample D plus KMnO4, the purple color of KMnO4 disappears and we have colorless solution. This shows that we have SO2 gas from SO3 2 minus here is confirmed. Now, the conclusive part of our teaching is that in our sample, for sample C, we have our cation and anions. So our cation for sample C, we have lead 2 plus, and our anion we have NO3 minus. This shows that we have lead nitrate as our sample C. For our sample D, we have our cation to be potassium ion and our anion to be SO3 2 minus. So what is going to be our possible salt? We have potassium sulfite. That's K2SO3. Thank you for watching. Please remember to subscribe to our channel, share with friends, and follow us for more updates. Thank you.